Today, we're gonna study about the mechanics of position. Mechanics of position includes gravity, the center of gravity, line of gravity, base, equilibrium, fixation, and stabilization. The base of support is defined as the area of support beneath the object. It includes the point of contact with the supporting surface and the area between them. These points may be the body parts such as feet or extension of body parts such as crutches or other walking aids. Another definition explains that base of support refers to the area beneath an object or person, which includes every point of contact that object or person makes with the supporting surface. Base of support is dependent upon two very important factors, which includes the center of gravity and stability. So if you increase the base of support, greater will be the stability, or greater the base of support, greater will be the stability. Did you ever notice when you're standing in upright position, feet parallel and close together, your body is less stable as compared to when we move our feet bit apart? This is all because of base of support. Increase the base of support, the greater would be the stability. Other factor is the center of gravity. The base of support is inversely proportional to the center of gravity. As you lower the base of support, the lower will be the center of gravity. Therefore, center of gravity must remain within the base of support. In order to maintain the stability and in equilibrium, in this figure, a boy is performing a high jump. The center of gravity moves upward and base of support is narrow. Consequently, jumper position is unstable, and if the base of support remains narrow, might be jumper will fall. Now in gymnastic activities, you can easily notice this principle. Or if we bend to pick up a child or a box, the knees should be bent and trunk flexed to move the center of gravity down and over the feet. If you look at all three positions, you will notice that position of center of gravity is high in standing position as compared to sitting and lying position. In sitting position, the center of gravity is located in bit lower position, whereas in lying position it is located near to the ground. Now, if you observe the line of gravity, you will find it high again in standing position as compared to sitting and lying position. But if you observe base of support, it's least in standing position, so we can conclude that body is more stable in lying position as compared to sitting and standing. Therefore, body is more stable in lying position as compared to sitting and standing. Walking aids such as canes and crutches increases the size of base of support and therefore allow more swing of the body without falling. In this picture, you can notice the relationship between center of gravity and base of support. So in figure A, the book is in very stable position because its center of gravity is in the middle of base of support. Whereas if you look in figure B, the book is looking less stable. This is because its center of gravity is near to the edge of base of support. Now have a look at figure C. The book is unstable and will fall because its center of gravity is beyond its base of support. In short, in order to maintain the equilibrium, the line of gravity must remain within the base of support. In this picture, you can clearly observe the effect of center of gravity, line of gravity and the base of support and can easily correlate the studied concept. Test your knowledge and guess which is the most stable position. When the resultant force is zero, the force system is said to be in equilibrium. That is no motion or you can say no change in position. All the objects at rest are in equilibrium. So equilibrium is defined as a state when all the forces acting on the body, that is, all external or internal forces which are acting upon the body, are perfectly balanced and body is remain at rest. In order to hold the football, a player is moving his head continuously, so the equilibrium between the forces remain constant. Perhaps if the resultant force is not zero, then motions occur. If we talk about the stable equilibrium, it is defined if the forces acting upon on the body at rest tend to restore to its original position. After it has been displaced, the body is said to be in stable equilibrium. Unstable equilibrium is defined if the body is given an initial displacement. The forces acting upon it increases. A center of gravity which is high as possible and a small base results in relatively unstable equilibrium, because even very small displacement cause the line of gravity to fall outside the base and the body will fall to the ground. For example, toe standing. When the force applied on the body, and in spite of displacement, the height and the position of the center of gravity remain in the same relation to the base of the body, then is said to be in nuclear equilibrium. Relative immobility is known as stabilization. So stabilization mechanism has been observed through electromyography studies, and they have shown that very little muscle activity is required in the normal leg standing position. Most action involves those muscles that act around the ankle. The minimal activity is necessary is attributed to the elastic properties of muscles, joint locking and retention from the passive strength of muscles, ligaments and fascia, which acts prior to muscle contraction of joint stabilizers. The body's stability is greatest when its center of gravity is low and its base of support is wide. Knee and hip joints are fully extended during weight bearing. The knee joints screw home by slightly rotating on the fully extended joints to provide joints from twin locking and provide them stability. Fixation is a means of preventing movements in joints and is used to improve the efficiency of muscles by fixing their origin or to localize movement in the performance of passive movements. There are two types of fixation: active fixation and passive fixation. Active fixation of joints is usually obtained by a slow contraction of muscles, either by the therapist or by the patient or by client itself. Passive fixation is achieved by means of manual pressure, straps, or sandbags. In orthopedic, passive fixation is performed by screws and wires as well.